Hi everyone, welcome to my channel Tech Initializer. So in this video, we will be implementing username password authentication using Spring Security. In our previous videos, we have discussed the internal flow and debugging between the filters, and we know the exact flow now. So just for a quick recap, we can go through the internal flow again. So we know whenever a client sends a request, it is intercepted by Spring Security filters. Spring Security filters like username password authentication filter will extract the username password from HTTP request, and it prepares an authentication type object. Because authentication is the core standard of storing authenticated user details inside Spring Security Framework. This authentication object is then passed to the authentication manager. So provider manager is the default authentication manager, and it tries to authenticate the request by going through all the authentication providers available. So the authentication providers contains the exact logic of authenticating the user details, and it uses user details service and password encoder. User detail service helps in retrieving, creating, updating, or deleting the user details from database. And password encoder helps in encoding and hashing the passwords. Otherwise, we have to live with plain text passwords. So once the request has been authenticated, the authentication will usually be stored in a thread local security context managed by the security context holder. So this helps during the upcoming request from the same user, and the response is sent back to the client. So let's start implementing username and password authentication. So before that, let's go through the pom.xml file. So in pom.xml file, I have added two dependencies, Spring Data JPA and H2 database. So H2 is an in-memory database that we will be using for storing our users and their respective roles. So let's start by creating user and role entities. So we will go into our domain package and we will be creating the role first. So it should be an entity, and it should be containing fields like private long ID, and it should also contain private string name, which will be the name of the role. So the ID will be marked as ID, and it should be generated automatically, and the strategy will be generation type dot identity, and for name it should be unique. So we can say the column unique is true, and it should not be nullable, and we will generate the getters and setters for this. Similarly, let's create a user entity. It should also be an entity. It should contain three fields: private long ID, private string username, and private string password. Later, we will be implementing user detail service that returns a user details object. So let's implement the user details for this user. So by default, it should contain some methods. Let's implement all of the methods that are required. So for the authorities, we will be having roles as well here. So let's create the role for the particular user, private set of role. We will call it roles. So there will be many-to-many relationship because a user can have many roles, and many roles can associate to many users. So that's why it should be many-to-many here, many-to-many. And we want to fetch it eagerly. And we need to cascade type all. So if we delete the user, the roles will also be deleted for the same user. And it should be joined with the table. Name should be user roles. So it will be a different table that will be created that will contain the mapping of users and their roles. The join columns, we need to join two columns. One will be join column name will be user ID, inverse join columns will be join column, and it should be the role ID now. So the mapping is done, and for the ID field as well, we need to have an ID annotation as well as the generated value, and the strategy will be identity, and for username it should be a unique constraint on that. So we'll be putting unique is true, and it should not be nullable. And for password also we need the same, unique attribute should not be there, and it should not be nullable. That's it we want. And now for the overridden methods, for the password we can just return this dot password. For username also we can just say this dot username. So for get authorities, we need to convert our roles into granted authority. We can do that by just streaming over the roles, and we can just map, and we will just get the name of the role, and then we can just convert it into a simple guaranteed authority. So it will take the role name and it will create a simple granted authority for that, and we can just collect it to a list. So that's it for the user and role entities. So it's the error here. Okay, I think I'm missing a comma here. Yeah, so we are ready with the entities. So user and role are now created. Now we will be creating a user repository to fetch the user details. So let's go here and create a new Java class. So now let's create a user repository. So it would be user repository, and it should extends JPA repository, and it would be of type user, and the ID will be long, and it should contain only one method that will return an optional of user, and it should be find by username, and it will take the username. That's it. So this is the user repository. Next we need to define our own user details service. So let's create a service here. Let's call it custom user details service, and it should implement user details service, and it should be of type service here. Also, I think we missed on the repository as well. There should be an annotation repository. So let's implement this user details service. Let's implement the methods. So they will be load user by username method, and this we need to override. So this method returns user details object. So that's why we in our user entity we have implemented user details, so that we don't need to convert it and we can just return it directly. So let's go back to customer user details service. Now here what we will do is we will just first we need to import AutoWire our repository here, user repository, and then we will be using this repository to just find by username, and then we will just pass the username. And since it returns an optional, so we need to do an extra step of or else throw, and we will be providing a supplier here that will be throwing an exception. It will say user not found exception, and the message will be user not found. So that's it for the user detail service. So now we have our own custom user detail service that we will be using in our custom authentication provider. Now let's create an auth request object that will be containing username and password, and the client will be sending that auth request. So in the DTO, if we can create a new record, which we will call it auth request, and it should be a record, and it will be accepting the username and password. So the auth request object is now ready. Now we will be writing custom username password authentication filter that will be replacing Spring Boot's default username password authentication filter. So let's create a filter here. Let's call it custom username password authentication filter, and it will be a component, and it should extend username password authentication filter. So we need to override 3 methods from this class. So let's override those 3 methods. Let's write an override implement methods. So the first one will be attempt authentication. Second one will be successful authentication, and the third one will be unsuccessful authentication. So we need to write our own logic in all of these 3 methods. So let's write a constructor for this filter, which will be public custom username filter, and it should accept an authentication manager. So the first call will be a super call where we will be passing the authentication manager to the parent, and then we need to define our filter process URL. This will be the URL for which this filter will be invoked. So we want the login to happen at /API/auth/login. So by default it is /login. If we go into the username password authentication filter, you can see super default and path request matcher is /login here. So that's why we are modifying it, and we want our login to happen at /API/auth/login. So now let's write the attempt authentication method. So in this method we will be first accepting our auth request, and we need to create a method to extract the auth request from the request. So we will be creating this method. So we'll write a try catch block. So here what we will try to do is we want to extract the auth request from the request object. So we will be using object mapper for that. So object mapper. So we will try to extract the request object read value, and it should be, let's read the request dot get input stream, and it should convert it to auth request dot class that we have created, right? So if there is an exception, we will just say throw new authentication exception, authentication service exception. It will just say authentication failed, unable to read request body, and we will just send the exception object here. So once we have extracted the auth request, we will just get the username auth request dot username and the password auth request dot password. Now we know security filters will create an authentication object. So in this scenario, the token will be of type username password authentication token, or authentication token, and it will be of type username password authentication token. And in this token we need to provide our username and password. So it will create a username password authentication token for us, for our own username and password that comes into the request. And once this token is created, we need to pass this token to the authentication manager. So we can just do by return, we can get the authentication manager, and we can just say authenticate this auth request token, authentication token. Just take this object and try to authenticate it. So this will be the scenario for attempt authentication. So the next method will be successful authentication method. So this method is invoked whenever the authentication is successful. So here what we want to do is we want to just save the authentication token to our security context holder, security context holder dot, we will just get the context and we will just set the authentication. We can then send a response to the client saying the login is successful. So for that we can just create a response entity of string, and we can just say response entity dot okay, we want to create, and we will just send the message login successful, and we need to set it in the response object, response dot set content type, content type, and status we can set by getting it from response entity dot get status code dot value. And the last thing, we need to write the body to the response dot get writer dot write. What we need to write is, we will again use object of object mapper and the write value as string, and we will get the response entity body, response entity dot get body. So with this implementation, we are just storing the successful authentication object in our security context holder, and then we are just sending the response back to the client that login is successful. Let's write the unsuccessful authentication logic. So here what we want to do is we will just send a response saying you are unauthorized. So we will create a new response entity object which will say your status will be http status dot unauthorized, and in the body we can just say it's an error, and we just say failed.message, failed.get message. So this will be the response entity in this case, and we can similarly send a response as we have done in the above method. So this is it for our custom username password authentication filter. So now we can write our own authentication provider. So let's go into let's create it in service. Let's call it username password authentication provider. and it should be type of component, and it should implements authentication provider. We will just implement the methods from this class. So there are two methods for this. So where we will try to authenticate and which authentication token it supports. So let's write the authenticate logic. So here this authentication object will be of kind username password authentication token. So we'll try to convert it into that. We'll say username password authentication token, and it will be kind of authentication token, and we will try to typecast it username password authentication token. We will extract the principal and credentials from this token. So we can say string principal is equal to authentication token dot get principal, and sorry, there's a typo here, and we can just cast it to string. And same case we can do it for password credentials equal to string of authentication token dot get credentials. So now we will be using our custom user detail service to load the user by username and try to match the password. So for that we need to inject the user detail service, custom user detail service, and also we need an encoder, password encoder. So now what we will try to do is we will try to get the user details using our custom user detail service dot load user by username, and we will be passing the principal here. Now once we get the user details, we try to match the password. So we will just say password encoder dot matches the credentials from the token as well as the credentials we get from the user details. So we can say if they doesn't match, we can just throw a new, we can throw an exception here called authentication service exception, and we can just say the message here invalid username or password. And if the password matches, then we can return a new username password authentication token with the username as principal, and the credentials will be the same, and we can load the authorities here as well. So this object will be authenticated object. This will be getting stored into the security context holder. For the support method, we are just supporting username password authentication token. So we will just say return username password authentication token dot class dot is assignable from authentication. So the authentication type, so if the authentication type is username password authentication token, then only this provider will be used. So now we have our own authentication provider. So now we have our own authentication provider and own custom user details service. So now the pending task is to create the security configs for our application. So let's go to the config package, and we can create our new class called Spring. We can just call it security config, and it will be a type of configuration. And let's enable the web security, and we'll say debug is true. This is not recommended for production, by the way, but to see what is happening in the logs, we can mark it as debug is equal to true. So let's create the beans required. So first we will be requiring the authentication provider, and just say authentication provider, and we can just return our custom authentication provider that we created. So username password authentication provider. So we have the authentication provider now. So we will create an authentication manager now. Public authentication manager, and it will be accepting authentication configuration, and it will just take the object from authentication configuration and just return it. That's it for this authentication manager. So I think it expects an exception, so let's add it to the method signature. We will be creating our own password encoder as well. So let's create a bean for that as well, password encoder. So we will be using bcrypt password encoder. So let's return new bcrypt password encoder. Yep, That's it. So now we have the authentication provider, authentication manager, password encoder as well. So now let's register our custom username password authentication filter as well. So we can create a bean public custom username password authentication filter, custom username password authentication filter, and it accepts an authentication manager. We can just return it and pass the authentication manager. So the next task is to create our own security filter chain configuration. So that's the most important one. So let's try to create that. So we will be creating a security filter chain, and it should accept an HTTP security object. Let's also inject custom username password authentication filter. We will be requiring it later. So yeah. So now, before defining request matchers, I have created a test controller here, which just contains two endpoints, test secured and test unsecured. So after we apply all the security configs, we will try to access the secured and unsecured endpoints. So we will be configuring this in our security config. So let's do that. So we can configure the request matchers dot authorize requests, authorize dot request matchers. So we want test secured endpoint to be accessed by only the person who has role as admin, has role. Here we just need to say dot has role admin, and also should be authenticated test secured is authenticated. So next we will be defining the endpoints that will be public to everyone. So that includes our login and logout endpoints. So request matchers API /auth/**. We will also define a logout endpoint just after this, and we will also be requiring it for the H2 console because we are using an H2 database, so it should be accessible to us. So that's why we don't want any secured mechanism on H2 console. And also there is one more endpoint called test/unsecured. We want everyone to access it without needing any authentication. So we will just say permit all. So now all these endpoints will be accessible to everyone and no authentication is required for these. So now we will be adding our custom username password authentication filter, and we will be adding it at the location of username password authentication filter that comes from Spring Boot. So for that we need to just do add filter at. So we just want to replace that filter, right? So that's why we can just say custom username authentication filter, and where it should go at the place of username password authentication filter dot class. Now we will configure the logout endpoint. So for the logout, we need to do some logout configurations. We need to define the logout URL, and which will be in our case /API/auth/logout, and we can also define to invalidate the HTTP session that is created on logout, and we can delete all the cookies as well if created with the name jsessionID. And next we can also configure the logout success handler. It will be taking the request response authentication. We will just be using the response object from here, response.set status logout successful. So that is it, and we will just return the HTTP .build and just build it. It requires an exception class, I think. Yes. So this is it. So for H2 we need to disable the frame options, otherwise we will not be able to access the H2 console. So for that we can just disable the frame options from here, dot frame option config. So this is just for H2 console, right? So before wrapping up the security config, I would like to talk about two more things. First one is security context, and second one is CSRF configurations. So in Spring Security 6, this is the default configuration for security context. It says require explicit save is defaulted to true. So what does this mean? So in Spring Security 5, whenever the login request is successful, the authentication object is stored in the security context, and security context used to be automatically saved to security context repository. and it was done by the filter with the name Security Context Persistence Filter. But in Spring Security 6, the default behavior is that the Security Context Holder filter, which replaced Security Context Persistence Filter from Spring Boot Security 5, will just only read the security context from Security Context repository and populate it in the Security Context Holder. And users need to explicitly save the security context with the Security Context repository if they want the security context to persist between requests. So this configuration, whenever our login is successful, will not save our security context into the security context repository, and hence for the future requests we will be getting forbidden because this context will not be found. And also the filter used will be security context holder filter and not the security context persistence filter. So if we want our security context to be saved to security context repository automatically so that it can be used for further requests as well until the session is valid, we can make it false. So by making it false, the filter used will be security context persistence filter and not the security context holder filter. So security context persistence filter will by default stores the security context into security context repository, and hence it can be used for future requests. I will show that you in the demo as well once we run this application. So next I will be talking about CSRF configuration. So by default, Spring Security block all the HTTP post, put, delete, and patch operations with an error of 403, which is forbidden error, if there is no CSRF solution implemented inside a web application. Since our login and logout are a post request, so they will be disabled by CSRF configuration. So we need to provide a CSRF config in order to ignore those requests from CSRF validity. So for that, what we can do is we can create a CSRF request attribute handler, and we need to provide our CSRF configs here, and we will be just ignoring the CSRF configs. So we can do it like this: CSRF config dot CSRF token attribute handler request matchers. We want to ignore CSRF from our API auth endpoints. So this will be a temporary fix and it's not recommended for production. So there are some extra configs that in order to generate a CSRF token, so which can be sent to UI after successful login, and the same token needs to be sent by UI for every subsequent requests which it is making to the backend. So for now this will be sufficient. So before running the application, I have created this data.sql file where we will be creating our roles, users. So there will be only one user for now, admin, and this is the password I have generated from bcrypt password encoder, and the password is password here. So I can show you the code where I have generated it. So in the Spring Boot starter application, use this piece of code where I am just injecting the bcrypt password encoder, and I provided the password as password, so it prints the password into the console. So you can also use that for creating your own users. I'll just delete this for now. Also show my application.properties file. So here I just have h2 related properties. So you can enable the filter chain proxy logger level so that you can see what's happening in the background related to Spring Security. And these two are related for inserting users and roles into the database once the DB is created. So let's run our application. So we are getting some errors here. It says roles not found. Okay, I think we need to define the table name here for our users and for our users as well as for roles. Also in user, the table we are in the data SQL, we are inserting in user roles. So it has to be user roles, not users role. So that's it. I think now we can run the application again. We can see now our application is up and running. So we have enabled the debugging. So that's why you are seeing this warning. You can disable that. This is not recommended for production. So you can disable that in production. So let's go to the postman and we'll try to create a login request. So let's do a login request. We're getting a 403 forbidden access. I think we have a typo in our CSRF configuration. Yes, we have a typo here. So we will just put a slash. Now we will stop the application and run it again. If we try to access it again, the login request, you can see its login is successful. So if we see in the logs, the security filters used are the security context persistence filter is used here. So the login is successful now. We can try to access the secured endpoint and we will be able to access the secured endpoint as well. And we can access the unsecured as well here. And if I do a logout and I try to access the secure endpoint, it will not allow me to do that. It gives me a 403 forbidden access. So now if we go to the logs and see which filter is being used, it was security context persistence filter. So this persistence filter will be saving the security context in the security context repository, and it is used for future requests. So that's why when you logged in and after that you access the secured endpoint, you were able to access it. And this is because of this one. So if we make it true, and if we stop the application, you start the application again now, I will make a login request again. So the login is successful. Now if I try to access the secured endpoint now, it will not allow me to access this, and it gives me a 403 forbidden. This is because, let's see in the logs. So now the security context persistence filter is not used. The filter used is security context holder filter. So this is from Spring Security 6, and it does not save the security context to the security context repository, and hence it is not used for future requests. So whenever I logged in, the security context is not saved into the security context repository, and when I try to access the secured endpoint, it can't access the saved security context because it was not saved, and hence it gave me a 403 forbidden access. So if you want to store your security context into security context repository, you need to provide this value as false so that security context persistence filter will be used. Hope this is clear now. I think that's it from this video. So thank you so much for watching. I hope this tutorial on custom username password authentication in Spring Security was helpful for you. If you found value in this video, please give it a thumbs up and consider subscribing to the channel for more content like this. Your support means a lot and it keeps me motivated to create more in-depth tutorials for you. And feel free to leave any questions or suggestions in the comments below. I would love to hear your thoughts. Thanks again, and I will see you in the next one, where we will be looking at short authentication using Spring Security.